Okay, this lesson is on standard deviation, and what we're going to do for this is there's a whole procedure for doing standard deviation. It's basically this 6-step procedure. It shows up on your formula sheet as well. But the general idea is that you find the mean, you subtract each value from the mean, you square each of those differences, you add up all those differences, divide by how many data values you have, and then you find the square root of that. So that is our standard deviation. And what standard deviation does is it tells us it's a measure of spread again, and it tells us how much our data kind of changes. So let's look at a sample of how to calculate the standard deviation. So we have 8 numbers here: 72, 68, 91, 63, 78, 86, 80, and 73. We find the mean first, so you add those together and divide by 8. And then this is best done in a table. So I created this table here. I list all of the values. I find out in the second column what's the value, subtract the mean. And if it's negative, it's negative. It doesn't matter, just write it down. The next column is the value minus the mean squared. So I just take that value and I multiply it by itself. And then I find the sum at the bottom, which is in this case 601.875. Once you find that sum, you divide it by the number of numbers, and that gives you what's called the variance. So in this case, the variance is 75.234375. The standard deviation is the square root of that number. So I find the square root, and I'm going to just round to the nearest tenth, and I end up with 8.7. So for that problem, the standard deviation is 8.7. So if you know the variance of a data set beforehand, you can jump straight to finding the square root of that to find the standard deviation. If you have the standard deviation and you want to find the variance, you just square that value. There is another version of this equation that we are not going to use in this course, but you will use if you have larger data sets. It's a standard deviation where you divide by n minus 1, so the number of values minus 1, rather than just the number of values. That's called Bessel's correction. We don't use it because we are not going to be using our data to extrapolate, but anytime you were looking at extrapolating with your data, you'll need to include that n minus 1 as your divisor. So one thing we can do with the standard deviation is we can determine how varied a data set is. And to do this, what you do is you compare the mean and the standard deviation. And you can divide the two together, and you'll get what's called the degree of variability. If you have a value for this degree of variability that's less than 1, then you can say the data is fairly consistent. If it's 1 or greater, then the data is not as consistent. So let's look at the second example. Here it says the standard deviation for this data set is 22.2. Is the data set fairly consistent? Now I'm just looking at it, and it looks like it doesn't really range too much. There's a low of 68, a high of 138, but generally it looks like the data is kind of consistently around 100 or so, and the mean is 108.25. So we to find the degree of variability, we do the standard deviation divided by the mean. We end up with 0.205. So because that's a fairly low number and it's less than 1, we can say that this data set is fairly consistent. Now let's try one of these problems out. I'll do the first one, and I'll leave the next two for you because it's a whole procedure to go through to solve these. So I'll let you guys kind of figure out that procedure. Let's look at doing this on an Excel file. So what I'm going to do first is I'm going to take all of those values that I have and write them down. So I'm going to write down 61, 48, 39, 46, 32, 46, 36, 60, 48, 31, 36, 54, 41, and 47. And I'm going to then find out what the average of this is, or the mean. So I'll just do the quick way of doing that. My mean is 44.64286. So I'll subtract everything from that. So 61 subtract this number, which is A16. And I will subtract everything from A16. So what I'm doing here is every one of these values, it's the value, so 48 minus 44.64, 39 minus 44.64, and I've written all of those down. I then have to multiply these by themselves, or I have to square them. And I end up with my square values here. So as you can see, if it's a low number, if it's like 1.35, which is 46, which is relatively close to the mean, when I square that, I get 1.84, which is pretty small. But if I have something that's farther away from the mean, like 60, which is 15 values away from the mean, and I square that, I get 235. So there's a big difference there. I will have to add all of these numbers together. And then I have to divide by the 14 numbers to get my variance. So my variance is 83.08673. Lastly, to find the standard deviation, I find the square root of that. And the standard deviation here is 9.115193. So if you were going to write this down, I would just write down 9.1. That's the whole procedure that I just ran through. Try that out for 2 and 3 as well. But try number 1 out. If you do this by hand, it's going to take a lot of writing, so you'll want to make a table. Doing this on a spreadsheet makes it a bit easier, because then you can get all of your calculations are done for you. Let's go back, and I'm going to show you what your assignment looks like. And your assignment is basically to complete a single standard deviation kind of project here. So what you see here is, let me just zoom out a little bit here. So you have some values here in this table. These are donations for a church. You then are kind of run through the procedure for standard deviation. So first you find the mean. Then you fill out the table. You find the variance, find the standard deviation. Then you ask a question, or you answer this question: are these donations fairly consistent? So that's the project for this. I won't work through this one because this is a static project, so you'll have to do this one on your own. But if you have any trouble, feel free to give me an email, and I'll help run through how to do standard deviation problems.